The James Webb Space Telescope has discovered hundreds of mysterious red dots that simply shouldn't exist. The light from these objects has been traveling to us for nearly 12 billion years, from the very dawn of time. It comes from something that shines with the brilliance of a young galaxy, yet is crammed into an impossibly small space. This anomaly is a puzzle that could rewrite the first chapter of the universe's history. What makes this discovery so vital right now is the instrument that made it possible. After launching in 2021, the James Webb Space Telescope began scientific operations in the summer of 2022. It was designed to see the infrared universe, the stretched-out ancient light from the cosmic dawn. And almost immediately, it saw something unexpected in its deepest images. Hundreds of tiny, perfect little red dots. These smudges of light are the visual echo of a time when the universe was less than 1 billion years old. This has left us with a cosmic mystery. First, how can something so compact be so astonishingly bright? Second, if this brightness comes from a giant black hole, then why is that black hole completely silent where it should be screaming with X-rays? And finally, could these red dots be something else entirely? A new type of celestial object we never knew existed. These little red dots, or LRDs, are some of the most distant objects ever seen. They existed during the universe's infancy, a period just 600 million to 1.5 billion years after the Big Bang. They are relics from the very first sunrise. JWST's near-infrared camera, or NIRCam, was the first to spot them in surveys with names like Fresco and Eiger. But seeing them was just the beginning. To understand them, astronomers used the telescope's spectrographs to analyze their light, and that's when the story got complicated. What this revealed is a hidden population of objects scattered through the vastness of the early cosmos that defy easy explanation.
In short, the James Webb Telescope found impossibly luminous objects in the universe's nursery. The first, most logical guess was that we were looking at the very first galaxies, each powered by a furiously growing supermassive black hole. But as another powerful telescope turned its gaze upon them, that simple answer began to fall apart. The initial theory was straightforward. These little red dots were baby quasars. A quasar is the intensely bright nucleus of a young galaxy powered by a central supermassive black hole feeding on enormous amounts of gas and dust. Astronomers using Webb's spectrographs found that the light from these dots contained broad emission lines. This is a classic signature of hot gas swirling around a black hole at incredible speeds, sometimes 1,000 kilometers per second. It seemed like a perfect match. The dots were red because they were shrouded in thick cosmic dust, and they were bright because of these powerful hidden black holes. These were thought to be the ancestors of the giant blue quasars seen later in the universe's life.
But this theory had a fatal flaw, and its discovery required a different kind of eye in the sky. If a black hole is actively consuming matter, it should release a torrent of high-energy X-rays. So astronomers pointed NASA's Chandra X-ray Observatory, the most powerful X-ray telescope ever built, toward these objects. They focused on a patch of sky called the Chandra Deep Field South, stacking observations of 55 different red dots for a total exposure time of nearly 400 million seconds. This was one of the deepest X-ray images ever taken, and it revealed nothing. There was no X-ray signal. This profound silence was a direct contradiction. It ruled out the possibility that these were typical, active black holes, even heavily obscured ones. The primary suspect had an alibi.
With the main theory in trouble, researchers like Joel Leja at Penn State and Anna de Graaf at the Max Planck Institute proposed a radical new idea. What if a little red dot isn't a galaxy at all? What if it's a single, colossal object they've nicknamed a black hole star? This theoretical object would be a supermassive black hole at the center, but instead of being surrounded by stars, It's cocooned in a gigantic, dense, turbulent shell of hydrogen gas. It glows not from nuclear fusion like a normal star, but from the incredible energy released as the central black hole devours the gas envelope from the inside. This model perfectly explains the key pieces of evidence. The dense gas would be very effective at absorbing any X-rays, explaining the Chandra non-detection. It also explains the unusual cold light signature. A special test case, an LRD nicknamed the Cliff for the sharp, steep drop in its light spectrum, had defied every conventional model. But when scientists applied the black hole star model, its bizarre spectrum fit perfectly.
This completely changes the question. We're no longer just asking how galaxies formed so early. We're asking if we've discovered a missing link in cosmic evolution. These objects could be the solution to a long-standing puzzle. How did supermassive black holes get so enormous so quickly in the early universe? Standard models struggle to grow black holes that fast, but a black hole star is essentially a turbocharged mass builder, an infant supermassive black hole in its earliest growth phase. Right now, the scientific community is buzzing with debate. Teams are running new simulations and reanalyzing every photon of light captured by Webb. Some scientists, like Fabio Pacucci at Harvard, are looking at the problem from another angle. His team suggests that the environment is the key. They propose that little red dots form inside extremely rare, slow-spinning halos of dark matter. These halos are the invisible cosmic cradles where galaxies are born. If a halo spins very slowly, in the bottom 1%, it allows gas to collapse into an incredibly dense core. This creates the perfect conditions to form either a compact starburst galaxy or a rapidly growing black hole star. This idea neatly explains why the dots are so compact and so rare, no matter what's powering them.
In the near future, astronomers will use more of the James Webb Telescope's precious time to get even more detailed spectra from these mysterious objects. They will be hunting for subtle clues in the light that can help distinguish between a dense cluster of stars and a single gas-shrouded black hole. Each new data point will help refine the models and get us closer to the truth of what these objects are and how they came to be. If the black hole star hypothesis is confirmed, it will fundamentally alter our timeline of the cosmos. It would mean that before the first great galaxies lit up the universe, there might have been an era of these strange, transitional objects. This discovery would provide a new pathway for the seeds of supermassive black holes to grow, solving a problem that has puzzled cosmologists for decades. It suggests that the universe had a phase that was wilder and more exotic than we ever predicted.
So, what is the answer to the promise we started with? Those impossibly bright, compact lights from the dawn of time are forcing us to reconsider our place in the universe. They are not simply young galaxies, they are a profound new puzzle. The leading and most exciting explanation is that we have found a new kind of object entirely, a black hole star, the nursery for the cosmic monsters that would one day anchor great galaxies like our own. The James Webb Space Telescope didn't just open a new window on the early universe, it showed us that out in the darkness, there are more things than are dreamt of in our theories.